Hello everyone, today we're going to be doing the Mathcounts 2000 National Sprint Round questions 16 through 20. The first question is, what is the largest integer value of n for which 8 to the nth power evenly divides 100 factorial? So first of all, what does it mean when you have a number and it has an exclamation mark behind it? This just means 100 factorial, which is the product of all positive integers less than or equal to the number multiplied together. So it's just 100 times 99 times 98 all the way to 3 times 2 times 1. So 100 factorial is a very, very big number. And we're asked to find what is the largest integer value of n for which 8 to the nth power evenly divides 100 factorial. So we're asked to find how many times can we divide 100 factorial by 8 and we get an integer result. So first of all, we can see here that 8, 16, 24, they're all divisible by 8. But let's see, if we have a 2, a 10, and a 14, for example, they all have a factor of 2 in them. A 2, a 2, and a 2. And if we multiply them together, we also get another 8. So we can derive an 8 without getting a factor of 8. So that means we have to be strategic and we have to make sure we count every single possible value. So first of all, we can observe that 8 is just 2 times 2 times 2. 8 is just 2 to the third power. So what we can do here is we can see how many times 2 divides into 100 factorial. That's going to be a lot easier. And then we divide the result by 3. So first of all, we can see how many even numbers there are. So we have 2, 4, 6, 8, all the way to 98 and 100. So here we can see that there are 50 numbers that are even. And from here we can move on to numbers that can be divisible by 4. And why do we do this? Because 4 has 2 factors of 2 in it. It's 2 times 2. So that means there's an extra factor of 2 we have to make sure we count. So we have 4, 8, 12. These numbers have an extra factor of 2, all the way to 96 and 100. So there's 25 numbers in here. And then same thing for 8. 8 has 3 factors of 2, so we have to make sure we don't forget about those ones. 8, 16, 24 to 96. There's 12 numbers here, and then we keep moving. 16, 32, all the way to 96. There's 6 numbers, and then 32, 64, 96. There's 3, and then finally we just have 64. So that's one number, and then we can add all these up. So 50 plus 25 plus 12 plus 6 plus 3 plus 1. And then our result is 97. So we can see 2 to the 97th power evenly divides into this number. So 2 to the 97th power evenly divides into 100 factorial. But we need to find how many times 8 can divide. And since we know that 8 is equal to 2 to the third power, then 2 to the third power, 2 to the 32nd power, and a third, that should be equal to 2 to the 97th. But we want to find the nearest integer because we can't have a third power. That doesn't create an integer. So we need to take 32. So that's just equal to 8 to the 32nd power. So our answer should be 32 for n. Okay, moving on to the next question. It says, in triangle ABC, C is a right angle. So we have a triangle here, A, B, C, and we know C is a right angle. And point M is the midpoint of AB, so M is over here. N is the midpoint of AC, so N is over here. And O is the midpoint of AM, so O is over here. And it tells us that the perimeter is 112 centimeters, and ON is equal to 12.5. And we want to find the number of square centimeters in the area of quadrilateral MNCB. So we want to find this area. So first of all, before we can solve for the area, we have to find some dimensions first. And we see that there are a lot of midpoints here, N, M, and O. A midpoint just divides a line segment into two congruent line segments. So M divides AB into two congruent segments, AM and MB. N divides AC into two congruent segments, AN and NC, and also O divides AM into AO and OM. And since we know that ON is 12.5, we can construct an imaginary line here, and let's call it D. And since O is the midpoint of AM, then D should also be the midpoint of AN. And because they're the midpoint, they should be equal. And OD should be equal to itself, and these two should all be right angles. So that means OAD is congruent to OND. So since ON is 12.5, that means AO should be 12.5 as well. And since O is the midpoint of AM, OM should also be 12.5. So we can clear off some stuff right now. So this is also 12.5. And then since M is the midpoint of AB, and we know AM is 25, then that means MB should also be 25, which means the hypotenuse should be 50. And there's two ways to solve for the other two lengths. The first way is just to find out that since the perimeter is 112, then that means the other two sides should add up to 62, and we can set an equation x squared plus 62 minus x squared equals 50 squared and solve it, but that's going to take some time. And there's another way, is memorizing your Pythagorean triples. One of the Pythagorean triples is 7, 24, and 25. And since 25 looks very similar to 50, because you can just multiply it by 2, we can multiply the other ones by 2 as well. We get 14, 48, and 50. And then surprisingly, 14 plus 48 is exactly 62. So these are the two sides that we want. So we can write it in there. And 48. And not all the time will it be so easy like that. And this works all the time. But if you memorize your Pythagorean triples, you wouldn't need to do that step, and it will be a little bit easier, assuming that it is a special right triangle. And to find the area of this weird looking shape, there's two methods. The first method is to recognize that this is a trapezoid. So we just need to find the length of the top side plus the length of the bottom side times the height divided by 2. And since ANM should be similar to ACB, because they both share a right angle over here, and then A is just equal to itself, so that means these two angles should be equal. And since we know that N is the midpoint, and we know that NC is 24, so it should be scaled down to half. So this should be 7. So we can construct our formula for 7 plus 14 times 24 divided by 2. Okay, that should be our answer. And we get 21 times 24 over 2, which is just 21 times 12, and that should be equal to 252. And the other method is also to find the area of the bigger triangle subtracted by the area of the smaller triangle. So the area of the bigger triangle is just the length of the two legs multiplied together divided by 2. So 48 times 14 divided by 2, and then we could simplify that a little bit. That's just equal to 24 times 14 minus the smaller triangle is 7 times 24. 7 times 24 over 2, and that should just be equal to 7 times 12. And then we also get the result that is equal to 252. So both ways we can find out that the answer gets us to 252, which means that we should be correct. But in an actual test, we wouldn't need to really double check our work that much if we're pretty confident that our first attempt is reasonable. And if we have time, you can go back and check. And so the answer to number 17 is 252. The next problem is, in each of the 3 boxes are 4 straws with integer lengths 1 cm through 4 cm inclusive. A straw is randomly selected from each box. What is the probability that a triangle can be formed with the 3 straws chosen? And it tells us to express our answers as a common fraction, which means we should expect a common fraction as our answer. So first of all, we can see how many total possible results can occur. So from the first box, there can be 4 results, 1, 2, 3, or 4. Second box as well, third box as well. So we can see here there's 64 possibilities. And we need to find a probability that a triangle can be formed. So we need to first know something about triangles, which is the 2 smaller sides must add up to be greater than the largest side. And then let's see, what if it's a triangle 2, 1, and 3? Why wouldn't that work? Since the greatest length is 3, then the smallest length is 1, and the smallest lengths are 1 and 2. This wouldn't form a triangle because 1 plus 2 would equal 3, and then technically we would just be getting a 2-dimensional line like this. So that wouldn't possibly make a triangle. So we know the 2 sides, any 2 sides should add up to be greater than the third side. And then we can test it out for this. So let's label the first box, second box, and third box. So from the first box, what happens if we pull a 1? And in the second box, let's say we pull a 1 as well. What can we pull from the third box to make sure we make a triangle? Well, we have to pull 1, because if we pull 2, 1 plus 1 is equal to 2, and we know that wouldn't work because that just makes a straight line. So 1, 1, 1 is the only possibility if 2 of the straws are 1. Let's see, 1, 2. Can we put a 1 here? No, because 1 plus 1 equals 2, so that wouldn't work. So 2 is the only one possible here. And the 1, 3, 3, 1, 4, 4. Okay, that should be equal to 4. Now let's move on to the 2's. So we have 2, 1, then it has to be 2. 2, 2, it could be 1, 2, 2, 2, 2, 2, 3. But 2, 2, 4 wouldn't work. 2, 3, 1 wouldn't work. 2, 3, 2, 2, 3, 3, 2, 3, 4. And finally, 2, 4, 3, and 2, 4, 4. So we can see how many are in here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 are in here. And then let's move over to this side. First, second, third. And then we get 3, 1, 3. That's the only possible 1. 3, 2, 2, 3, 2, 3, 3, 2, 4. 3, 3, 1, 3, 3, 2, 3, 3, 3, 3, 3, 4. And then 3, 4, 2, 3, 4, 3, and 3, 4, 4. And then let's see how many are in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 are in here. And then for the last one, 4, 4, 1, 4, 4, 2, 3, 4, 2, 4, 4, 3, 2, 4, 3, 3, 4, 3, 4, 4, 4, 1, 4, 4, 2, 4, 4, 3, and 4, 4, 4 all work. So as we can see here, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's another 10 in here. And then we can count the total amount. So 9 plus 11 should be equal to 20. And then 20 plus 10 is equal to 30, 34. And so our answer should just be 34 over 64. And it asks us to express it in a common fraction. So this can be reduced. They both have a factor of 2, so 17 over 32. So our answer should be 17 over 32. That's the answer for number 18. The next problem is, Alyssa rode her bicycle for 7 hours. She started on level ground and rode at a rate of 8 miles per hour. She came to a hill that slowed her down to a rate of 5 miles per hour. Upon reaching the top of the hill, she turned around and descended at a rate of 20 miles per hour. Finally, she returned home on the flat portion at 8 miles per hour. What is the total number of miles that she rode? So essentially, on the level ground, she rode for 8 miles per hour. And then on the hill, it's going to slow her down to 5. And then she comes down again. Actually, it should be to the left, but we don't have space, so let's just write it on the right. She goes down 20, and these two should be equal to the same because they're the same hill, and comes back with 8 miles per hour. So the first way I approached it is just by solving, maybe like put the distance of the ground as D, and then the distance of the hill as H, and then the time as A, and then there's also A, but there's just too many variables, and then I think it's impossible to solve with that many variables with that little equations. But there's another way we can approach it. So first of all, we need to know the distance, time, and velocity formula, which is time times velocity is equal to distance. So what we can do here is we can split it up and then combine it together. So first of all, the time to ride on the flat ground, let's call the flat ground the distance D. We don't know now, but we can change the equation around a little bit. So D, let's call that the distance of the level ground, and she rode at a rate of 8 miles per hour. So we have the time 1, the time she rode for the first portion is equal to D over 8. And then at the second portion, when she's climbing up the hill, the distance is H. Let's call it H for hill. And then we know she went at a rate of 5 miles per hour, so over 5. And T3, she goes down the hill, same logic, and then T4 is just the same route, so D over 8. Then you might be wondering, why do we have so many T's? Isn't that also a lot of variables? But you have to remember, she said she rode the bicycle for 7 hours. So if we add it up together, T1 plus T2 plus T3 plus T4 should be equal to 7. That means we can set up an equation. 7 is equal to D over 8 plus H over 5 plus H over 20 plus D over 8. And then we can combine some of the variables. So D over 8 plus D over 8 is just D over 4. 7 equals D over 4 plus H over 5 can be changed into 4H over 20. And a 4H plus H is 5H over 20. So we get H over 4. And then we multiply it. We get 28 is equal to D plus H. And then since we know what D plus H is, we know what the distance was on the level ground and the hill was. But we want to know the total miles she rode. And we know that she went on both twice, so we just multiply by 2 and we get 56. So that means she rode a total of 56 miles. Okay, ending the video with an easier question. The probability of drawing a red marble from a jar of marbles is 1/5. If 3 marbles are drawn with replacement, what is the probability that none of the marbles drawn is red? Express your answers as a common fraction. And here a key word is with replacement. So what it means is after you take out a marble, you put it back in before you draw the next marble. And how many marbles are in the jar? We don't know this, but we know it's a factor of 5, but we're not really sure. Do we need to know how many marbles are there? Well, it doesn't tell us, and that should mean that we don't need it. And it's asking us for the probability that none of the marbles drawn is red. So let's think about it. On the first draw, the probability of getting a red marble is 1/5. So that means on the first draw, the probability of not getting a red marble is just 4/5. Okay? And then we know it's with replacement. So after you draw it, you just put it back in, and the probability is still the same. So when we're drawing the second time, the probability is still 4/5, and the third time is still 4/5, and we just get 4 to the third over 5 to the third. That's 64 over 125. So our answer for number 20 is 64 over 125. So that's the problems 16 through 20.